and welcome to the first tutorial of GRE Quant. We are going to discuss about integers and its properties. The definition of an integer is that it is a number that can be written without a fractional component. For example, 2, 0, 4, -8, -900, etc., etc. Integers are a combination of positive and negative numbers, including 0. 4x equals 20 means x is an integer, that is 5. Now the same expression, 20 divided by 4 equals 5, can be written in a number of ways. For example, it can be written as 20 is divisible by 4. Dividing 20 by 4 gives us a remainder of 0. 4 is an exact divisor of 20. 20 is a multiple of 4, and 4 is a factor of 20. Remember, GRE tests your conceptual and problem-solving skills, and therefore it is going to throw you questions in a twisted manner. One of the properties of integers is that if x and y are multiples of z, then x plus y and x minus y will also be multiples of z. Which means that if 20 and 15 are multiples of 5, then 20 plus 15, that is 35, and 20 minus 15, that is 5, will also be multiples of 5. Now this is not a property of integers, but kindly keep this in mind, that if the value of x is between 0 and 1, and the value of y is also between 0 and 1, then x into y will be less than x, and x into y will be less than y. For example, if x is 0.7 and y is 0.3, then xy is equal to 0.21. That is, it is less than 0.7 and it is also less than 0.3. Let us now discuss even and odd integers. Even integers are numbers that are divisible by 2, and odd integers are numbers that are not divisible by 2. Evens and odds include negative numbers also. 0 is even. Even numbers are divisible by 2, as we have already discussed before. Even number can be expressed as 2k, where k is an integer. That is, any integer that is multiplied by 2 will be an even integer. The prime factorization of an even number will include at least 1, 2. For example, 6 is an even number and has 4 prime factors, that is 1, 2, 3 and 6. That is, 6 has at least one prime factor, that is 2. Odd numbers are not divisible by 2. The prime factorization of an odd number will not include any 2's. Odd numbers can be expressed by 2k plus 1, where k is an integer. For example, if k is equal to 3, then 2k is equal to 6, and 6 plus 1 is 7, which makes it an odd number. Now, if x is a multiple of z and z is a factor of y, then y will be a multiple of z. For example, let x equals 6, y equals 4, and z equals 2. Then x plus y, that is 10, and x minus y, that is 2, will be multiples of 2, that is z. Z is a factor of x and y, that is 2 is a factor of 6 and 4, and it is also a factor of x plus y, that is 6 plus 4 is equal to 10, and it is also a factor of x minus y, that is 6 minus 4 is 2. X plus y divided by z and x minus y divided by z will be an integer. That is, 10 divided by 2 and 2 divided by 2 will be an integer. Lastly, if x is divisible by a multiple of 2, then x will be even. Let x equal 20 and multiple of 2 equal 4. Then if 20 is divisible by 4, x will be even. In this slide, we will be discussing operation of addition, subtraction, multiplication and division on even and odd integers. In case of addition and subtraction of even and odd integers, if even integer is added or subtracted by an even integer, we are going to get an even integer. Similarly, if an odd integer is added or subtracted by another odd integer, we are going to get an even integer. On the other hand, if an even integer is added or subtracted by an odd integer, we are going to get an odd integer. If you play it with more than two integers, then the respective property of an even or odd integer may change. For example, if 4 plus 2 is 6, and if we add or subtract 3 by 8, we are going to get an odd integer. In case of multiplication of even and odd integers, even into even integer is going to give us an even integer, but odd into odd is going to give us an odd integer. And even into odd integer is going to give us an even integer because of the factor 2. Now, in division of odd and even integers, an even integer divided by an even integer is going to give us even, odd, or a non-integer. Odd divided by odd is going to give us an odd or a non-integer. Odd divided by even is always going to give us a non-integer. And even divided by odd is going to give us an even or a non-integer. I would suggest, in order to better understand the expressions, kindly try adding. Consecutive integers are integers that follow each other in order. Kindly note that in a set of consecutive integers, the mean and median are equal. Examples of a set of consecutive integers are -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, and so on. We can have even consecutive integers, that is -4, -2, 0, 2, 4, 6, 8. And we can also have odd consecutive integers like 1, 3, 5, 7, 9, 11. There are many examples of consecutive integers. Now the expression n plus 1, n plus 2, n plus 3 can help us in understanding the order of consecutive integers, even in the case of negative integers. Kindly note that in a set of consecutive integers, that is 1, 2, 3, 4, 5, every second integer is divisible by 2. Every third integer is divisible by 3. Every fourth integer is divisible by 4. And every fifth integer is divisible by 5. In general, every nth integer is divisible by n. You can understand it by replacing n with integers. Now, if we have two consecutive integers, that is 2, 3, 10, 11, 15, 16, 98, 99, one of the numbers must be divisible by 2 and one of the numbers must be even. In case of three consecutive integers like 6, 7, 8, one of the numbers must be divisible by 3 and at least one of the numbers must be even. This shows that in case of n consecutive integers, one number must be divisible by n. For example, if we have two numbers in a set, that is 1 and 2, then one of the numbers must be divisible by 2, as we can see it here too. 2 can be divided by 2 to give us an integer. In case of consecutive integers, that is n plus 1, one number must be even. Product of the numbers must be even, that is odd into even into odd is equal to even, as we have already discussed it in the multiplicative property of integers. if we look at the expression n cubed minus n, it can be split further, giving us an expression of 3 consecutive integers. For example, if we have 3 consecutive integers, 2, 3, and 4, at least one number is even and one number is divisible by 3, and the expression must be divisible by 6. The good news is that we are done with today's tutorial on integers. I hope you have understood it well. I have prepared a few questions with solution on the same topic, which you will see in another video. I'm going to upload it in a bit. Kindly solve these questions yourself before looking for their answers and solution. In case you have any confusion, kindly leave your comments under the video. Thank you very much and best of luck to you.